Hello and welcome back. Today we get to work in section 7.2 on partial derivatives. So the idea here is that instead of working in just a regular flat surface XY plane, we're thinking of working in three-dimensional space. With partial derivatives, we basically want to hold either one variable or the other as constant and work with the other. So for example, if they tell us that f of xy, so remember this, this is sort of akin to the variable z, is negative 3 x to the fourth plus 6y squared minus 11. If I want the partial derivative with respect to x, the notation of that, I don't want to use prime anymore. The reason I don't want to use prime is we have two independent variables. I have to state which one. So the agreed upon notation of that is actually to write it as a subscript. So f sub x of xy is indicating the partial derivative with respect to x. So this is how we would indicate that to the reader. We've got our little subscript x there, so they're saying partial derivative of function f. Which one are we treating as if it's a variable at the moment? X. So the negative 3x to the fourth derivative would be negative 12x to the third. Now, even though 6y squared is a variable term, if we're differentiating with respect to x, that means basically pretend y is a constant. So derivative of a constant is 0. Derivative of negative 11, also 0. Those will drop off on us. So let's keep the same f of xy, but this time we'll find the partial derivative, this time with respect to y. Notation shouldn't be a huge surprise here, similar except a subscript y. So partial derivative of function f, treating y as if it were the variable. So in other words, now we pretend x is a constant. So now that negative 3x to the fourth is treated as if it were just a 2 or an 8 or an 11 or a pi. Any constant, derivative of a constant is 0. That term drops off on us. Derivative of 6y squared would be a 12y, and derivative of a constant, any constant, is always a nice pretty 0. So next, we'll look at some of the other notation. Again, I had mentioned that z is sometimes used as our third variable. So if they tell us that z is equal to 7xy to the fifth plus e to the 3xy power, if they ask for, here's another notation, partial derivative of z with respect to the variable, let's do this one with x. So y to the fifth is treated just like the 7 is. It's just part of my constant. So I'll hang on to the 7y to the fifth. Derivative of x is just a 1. Same thing on the next term. Not only is the 3 a constant, y is also treated as if it were a constant. And if you'll recall, the derivative of e to the cx is ce to the ex. So here our c is a 3y. So plus 3y e to the 3xy. And typically we would write it without the times 1 there. So the partial of z with respect to variable x would be 7y to the 5th plus 3y e to the 3xy. So the next place they have us apply this is with a quick application problem related to a word problem we did in section 7.1. So if you'll recall from section 7.1, we have two types of swings. Type A was $150 each to produce them. Type B cost $100 each to produce, to make. And they told us we had $5,000 in fixed monthly cost. So that created for us the cost function C of AB, which was 150A plus 100 times B plus the 5,000 a month in fixed expenses. So what we're going to do different this time is we're going to find and interpret C sub A of AB and C sub B of AB. So we'll start with C sub A. So this is saying take the derivative of function C, treat A as a variable, treat everything else as if it were a constant. So derivative of 150A, if A is my constant, would be 150. Derivative of 100B, if A is my variable, would be a 0. Derivative of 5,000 is always a 0. So if A is my input variable, derivative of 150A is 150. Similarly, C sub B of AB, see if you can go ahead and pause it if you need to and find that value. Welcome back. So C sub B of AB. Now our A is being treated as if it were just a number, and derivative of a constant is 0. That term drops. Derivative of 100B, if B is my variable, is now 100. Derivative of any constant is 0. So there's the find part, the interpreting part, what that actually means. If B is held constant, cost will increase. We know it's an increase because we have a positive derivative by $150 for each additional A swing. And similar definition for the other. If production of A is held constant, costs, well, we're still increasing since our derivative was positive. In this case, increased by $100 for each additional B swing. So that would be what our interpretation means. So cost, or if you want to be very specific, you can say total cost. All right, so that's a little bit of an application using the word problem from the previous section. Next, I want to talk second derivatives with these partial derivatives. So first, let's get a function to play with. So we'll call it z is our f of xy. And for this one, we'll use 2x to the fourth minus x e to the y plus 3 times y. So we'll start by finding f 2 subscript x's, and it means exactly what you think. Differentiate with respect to x, differentiate with respect to x again. So first I have to find f sub x of xy. So I'm differentiating this. Only the x's get treated like variables. All of the y's get treated as if they were 2's, 5's, whatever. So 2x to the fourth derivative with respect to x would be 8x to the third. My second term here, e to the y, we treat it as if it were a constant. So I would keep this minus e to the y, and derivative of x is just a 1. Derivative of 3y is 0, since we're differentiating with respect to x at the moment. So that would be 8x cubed minus e to the y. So my second derivative, also with respect to x, I just differentiate this first derivative, again treating x as if it's the variable, y is just a constant at the moment. So that would be a 24x squared. Derivative of minus e to the y is 0. That would drop off since y is being held constant at the moment. So I'm going to ask you to pause it and find fyy of xy. Okay, welcome back. So first you had to find f sub y of xy. So we're differentiating this function, treating x as if it's a constant, y is a variable. So 2x to the fourth is a constant at the moment. Its derivative is 0. Goodbye to that term. This minus x is treated as if it's a constant, so I'll hang on to that constant. And derivative of e to the y is still e to the y. And the derivative of 3y, this time with respect to variable y, would be a positive 3. So once you had that in hand, then you were ready to take the derivative of your derivative. Again, with respect to the variable y. So minus x is still a constant. Derivative of e to the y is still e to the y. Derivative of any constant is always 0. So hopefully you got minus x e to the y for your second derivative with respect to y both times. So next I want to look at f sub yx. So first I'll find f sub y of xy. So you found that just a moment ago, minus x e to the y plus 3. The only thing different now is that we switch it up. So we already have the y. Now we're just bringing down an additional derivative of x being the variable. So I take this answer, and now y gets treated like a constant. X is now my variable. So this derivative, remember, minus and e to the y would all be constants, and derivative of x is just a 1. Derivative of any constant is 0. If they asked me to find f of xy, f sub xy of xy, I'll end up with, in this case, the same end result. I'll just do it in a different order. So first we would find f sub x of xy. So f sub x of xy, we found that a couple of minutes ago. That was 8x cubed minus e to the y. So then we take that and differentiate this time with respect to y. So now 8x cubed is a constant. It drops off. Derivative of minus e to the y is still minus e to the y. So they did turn out the same in either order. For the problems you'll see in this class, that would be the general case. I can say that that is always the case in every multivariable problem, but all of the ones we'll see it is the case. All right, so next up, we'll look at another quick application. So for this one, use one of your author's examples. So two types of, really selling here, lotion. And our demand, X ounces per day of brand A and Y ounces per day of brand B. So basically you're in a store, two different types of lotion, and you ran the numbers. X ounces a day you move of A, Y ounces a day of brand B. And you notice X is 100 minus 5P plus 2Q. We'll define these in a moment. Y is 50 plus 2P minus 5Q. So what do P and Q mean? So P is our price in dollars per ounce of A. Q is similarly defined for B. So the signs, at least, shouldn't be super surprising on this. Your demand for ounces of brand A, P has a negative coefficient. If you increase the price of brand A, there's going to be less demand for brand A. Similarly, if you kept the price of A the same but started increasing the price of brand B, it's going to push some of those brand B customers over to demanding more of brand A. And we see a similar sign thing on here for our demand for brand B, positive in terms of P, so increasing the price of brand A will increase the demand for brand B, as well as a negative slope on Q. So in other words, as the price of B goes up, demand for B will go down. It's getting more expensive, fewer people are going to buy it. So for this one, we're going to find and interpret partial of x with respect to variable p. So first off, this is telling me what equation to look at. I'm looking at the equation that has the x equals, and I'm treating p as if it's a variable, so q is at the moment a constant. So derivative of the 100 is always 0, no matter what variable we're working in. Derivative of any constant is 0. Derivative of negative 5p, since p is the variable, that derivative is negative 5. So the derivative of linear is constant. Derivative of 2q, q at the moment is being treated as if it were constant. That will drop off. So partial of x with respect to p is -5. So what does that mean in English? If we want to think of this as a slope, remember a slope, you can always, if you want it to look like a fraction, you can always think of it as over 1. So p is changing by +1. What is p again? P is the price per ounce of brand A. So as the price of A increases by $1 per ounce, what happens to change in X? And X, remember, is number of ounces of brand A. The demand for brand A will, this is negative this time, so decrease instead of increase. And X is measured in ounces per day. So decrease by 5 ounces per day. And this is all assuming price of B is constant. So we do need to include that assumption as well. That's the most commonly forgotten part of the interpretation. Okay, so that should give you enough to work your way through the 7-2 problems. So 7-2, the problems I would recommend. Let's see, I have that written down right around here. There we are. I would try 1 through 15 on the odds, 17 to 51 every other odd, 77 and 79 were also some interesting problems. If you have any questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.